Hi, this is Nathan Tintle. In this Learning Goal video, we will discuss the validity conditions for ANOVA. We will use the Recalling Ambiguous Prose dataset to talk about this learning goal. For any theory-based test, you should know by now the validity conditions are needed in order for the prediction of the null distribution to be reasonable. One approach to validity conditions directly extends what we've seen earlier and then builds on it. You should have at least 20 observations in each group without strong skewness. Or if you have less than 20 in one of the groups, the data should be symmetric within the group. Now, while that one builds directly on what we've seen before, ANOVA, this F-statistic approach, does have an additional validity condition that must be true, and it has to do with the standard deviations. Essentially, the standard deviations should be similar within each of the groups. One way to talk about similar is within a factor of 2 of each other. Let's see how that looks on the ambiguous prose data. Here's the ambiguous prose data. First validity condition, our sample size is 19, right at that threshold of where we're saying, avoid strong symmetry versus make sure they're symmetric. We're looking at this data here. The data is fairly symmetric. Our sample sizes are all right near that 20 threshold. We're good on the first condition. Second condition, are the standard deviations close? 2.01, 1.82, 1.46, is that close? Here's how you can check close. 1.46 times 2, so take the smallest standard deviation, double it, you get 2.92. That's bigger than the biggest standard deviation. What that means then is that these standard deviations are within a factor of 2 of each other. Smallest one doubled is bigger than the largest one. If that's true, they're within a factor of 2 of each other, and that's generally accepted as the standard deviations are fairly similar. Few words of caution. What should you do if the validity conditions are not met? Use simulation. You can simulate either using the F-statistic or the MAD statistic. Either one is okay, but don't use the theory-based p-value. Simulate instead. Remember that the validity condition here is not just sample size and symmetry anymore as it has been before when we've looked at one mean or two means. The standard deviations also must be similar across the groups when you're doing an ANOVA. And finally, what does it mean for the standard deviations to be similar? They should be within a factor of 2 of each other. If you double the smallest one, it's bigger than the largest.